Hi everyone, welcome to Smart Math Online Tutor. Through this video, we are going to look into factors. So let's get started. First of all, we are going to see what highest common factors are. Remember, a highest common factor of a set of given numbers is the biggest common factor. And by this highest common factor, all the given numbers can be divided without a remainder. Now, let us see how to find the highest common factor of a set of numbers. Look at this example. It's 4, 8 and 12. We are going to find the HCF. The first step is divide these three numbers separately by the prime numbers and get the prime factors like this. So, accordingly, 4 can be written as 2 into 2, 8 can be written as 2 into 2 into 2 and 12 can be written as 2 into 2 into 3. So then our next step is to find out the common prime factors for these three numbers. Now you can see 2 is common in all the three. So let me circle it like that, and another 2 is common in all the three numbers. So I can circle it another time like this. Then the highest common factor is taken as 2 into 2 because there are two 2's in common for these three numbers. So 4 becomes our highest common factor. Now if you see carefully, 4, 8 and 12 can be divided by 4 without a remainder. Therefore, our highest common factor of these three digits is 4. Now let's see how to find the highest common factor of several algebraic terms. Now look at this example. We are going to find out the highest common factor of these three algebraic terms. So remember, the first step is to write the three algebraic terms in terms of their prime factors. Right? The coefficient must be written in terms of the prime factors and the algebraic terms can be written as it is. Now look at this. 4x, you know 4 is 2 into 2 into x, and 8 can be written as this. Now x and y I have written as a product, and then 6xy squared can be written like this. Now once again, what we do to find the HCF is to find out the common terms. Now common terms, if you take, you can see in all the three algebraic terms 2 is common. So let me circle it like that. And then if you go to the next terms, then x is common. So I can circle x like this. Now there is no other common term for all the three algebraic terms given. Therefore, the HCF we write as 2 into x, that is 2x. So this is how we find the HCF of several algebraic terms. Let's look into another example. Now in this case, it is 7mn, 14mn squared and 21m squared n. So here 7mn can be written like this. 7 is a prime number, so 7 I have written as it is. And then 14 I have written as 2 into 7 into m into n, and then 21 like this. Now if you see here carefully, what is common? 7 is common, m is common, and n is common in all the three terms. So our HCF becomes 7mn. Right. In the next section, we are going to see how to write an algebraic expression as a product of its factors. So let me explain you how to do this through an example. Now see here, 4x plus 8y. We are going to factorize this. Factorizing means taking or writing this expression as a product of two or more terms. Right. Now the first step is we write each term in this expression in terms of its prime factors. Now if you take 4x, I can write 4x like this. And if you take 8y, I can write down 8y as a product of prime factors like this. And then I circle the common terms, and like before, I find out the HCF. So HCF of these two terms is 4. Now what I do is I take 4 out of a bracket and the remaining when 4 is taken out. In 4x, when 4 is taken out, x is remaining. In 8y, when 4 is taken out, 2y is remaining. Now you can find out that part from here. See, x is remaining here, 2y is remaining here. So those two I have written inside the bracket. Right? Now this is the answer for the expression 4x plus 8y can be factorized as 4 into x plus 2y. Let's look into some more examples. Look at this here. 15a plus 3b minus 12. Now once again, I write each term in terms of its prime factors like this. 15a is 3 into 5 into a. Then 3b can be written like this. And 12 can be written as 2 into 2 into 3. So the HCF is, now you can see 3 is common and only 3 is common. No other common terms. Therefore, HCF becomes 3. Now what I do is take 3 out of a bracket and the remaining here, 5a here, b here and 4 here. I have written inside a bracket. The symbols have not changed. Plus and minus in the expression have not changed. So then our answer is 3 times 5a plus b minus 4. Now let's look into another example. This example, I'm going to just show you a different method. Now that is, what we do is at a glance, when you look at this expression, 5p plus 30q minus 15. So when you look into these three terms separately, 5p, 30q and 15, at once you can see all the three terms can be divided by 5. Right? So what I do is I divide each term by 5. See here, 5p I divide by 5 and take the answer as p. Then 30q I divide by 5 and take the answer as 6q. And 15 I divide by 5 and take the answer as 3. Now this digit which I divided, that is 5, I take out of a bracket and this part, this section, I write inside the bracket like this without changing the symbols. Here plus and minus is not changed. I have written it as it is. So this can be done in factorizing as well. This is another method and you have to make sure you consider or you select the highest common factor so that the terms inside the bracket will not have any other common factors. Right? Let's do another example in this method. PQ plus 3P. It's very clear. PQ can be written as P into Q. 3P can be written as 3P. So the HCF becomes P. So when you take P out of a bracket, within brackets you have to write Q and 3. And look at this example. I can see that 18, 24 and 12 can be divided by 6. And in all the three terms, there is an x. So I divide all the three terms by 6x separately. So 18x, if you divide by 6x, the answer becomes 3. 24xy, if you divide, the answer becomes 4y. And 12xz, if you divide by 6x, the answer becomes 2z. So now I take 6x out of a bracket. And the three answers I have written within the brackets. Moving on to the next part, algebraic expressions with negative factors. Now what we do here is, if they ask you to write the given expression with a negative factor, we have to take a negative number out of the brackets. So in that case, look at this example, minus 3x plus 6y. You can see both minus 3 and 6 can be divided by minus 3. So since we have to write it as a factor with the negative term, we select minus 3. I select minus 3 because both 3 and 6 can be divided by 3. Since it should be a negative factor, I take minus 3. So now Minus 3x divided by minus 3 is 1. 6y divided by minus 3 is minus 2y. So then I take minus 3 out of a bracket and within brackets I write down 1 minus 2y. This 1 and minus 2y is this part and this part. Okay, right. Let's go to another example. Minus 5p plus 20 cube and minus 35. Very clearly you can see all the three terms are divisible by 5. Since we need a negative factor, I take minus 5. So let's divide each term in this expression by minus 5 like this. And then our final answer will be minus 5 times p minus 4q plus 7. Now in this case here, this is p minus 4q and here 7 doesn't have any symbol in front of it. If there is no symbol, you should remember it's plus. So I have put plus here. Right. So you have to remember few things when you factorize algebraic expressions. The first thing is find the HCF of the given terms and then take the HCF as one of the factors and the other factor you have to find out by dividing each term by the HCF. And then write the algebraic expression as the product of these two factors you found above, that is the HCF and the part which you got by dividing the given terms by the HCF. And another important thing is you can double check your answers by removing the bracket and obtaining the initial expression. That is, once when you remove the bracket, if you are getting the first expression in the question, then you can make sure your answer is correct. So, hope I made myself clear with factorizing and HCF. See you with another Smart Math clip. Until then, goodbye.